The very last lesson involving sequences and series is going to talk about recursive rules. We've so far only used explicit rules. And an explicit rule gives a sub n, the term you're trying to find, as a function of the term's position number. So based off the first term, okay, what would the value of the 13th term be in the sequence? Whereas a recursive rule gives the beginning term or terms of a sequence, and then a recursive equation tells how your term is related to one or more preceding terms, so a term before. So a recursive rule here, guys, is really, we find it based off of the previous term. So the only way to use a recursive rule is if you know the term right before it. So the only way you guys can use a recursive rule is if you know the term previous the one you're trying to find. So the only way to use a recursive rule if you're trying to find the 13th term is knowing, okay, well, what would the 12th term then be if the rule you're using is recursive? So it asks us, write the first 6 terms of the sequence. So the thing that's a little different here is a sub 0. And that's just another way, instead of writing a sub 1, it's actually taking that first term and subtracting the difference. So a sub 0 is still your first term. So the 6 terms that we're trying to find are a sub 0, 1, 2, 3, 4, and 5. So all you guys are doing is saying, okay, well, a sub 0 is 1. It tells us that much. Great, fantastic. So what would a sub 1 be? Well, a sub 1 is going to be 4 plus the term before it. That's what n minus 1 stands for. The term number of the term you're finding minus 1. 1 before it. So a sub 1 would be 1 plus 4, which equals 5. So a sub 2 will be a sub 1 plus 4, the term before it, plus 4. So 5 plus 4 equals 9. A sub 3 will be the term before it, which was 9, plus 4, which equals 13. A sub 4 will be the term before it, which is 13, plus 4 gives us 17. And a sub 5 will be the term before it, 17 plus 4 equals 21. So in order to use a recursive rule, you have to use the term before it. You're not just plugging in a value into a rule based off of its term number. You're plugging in a value based off the term before it. So go ahead and try number 2. So it gives you a sub 1, and it wants you to find the first 6. So it wants you to find a sub 1, 2, 3, 4, 5, and 6. Start with the first, and then you plug them in to continue your sequence. So just like for explicit rules, guys, we also have recursive equations for arithmetic and geometric sequences, both kinds. So your arithmetic sequence is just the term before it plus the difference. The geometric sequence is the term before it times the ratio. That's it. If you know term 2, to get to term 3, take that term, multiply by the ratio, continue on. Arithmetic, if you know the term before it, add the difference, that will get you the next term. Go from that term, add the difference again, it'll get you the next term. So write a recursive rule for the sequence. So if we're looking at number 3, it is possible for these to not be arithmetic or geometric. So if that's the case, we're going to have to find our own unique rule. So if I'm looking at this, 100 to 40 is 60 of a difference, but it's not a difference of 60 from 40 to 16. So the next thing you want to do is look for a ratio, and I work backwards. So I would say, okay, if I divide 64 25ths by 32 fifths, and then 35ths divided by 16, because remember, if I'm working backwards, a ratio is multiplication. So to find that, if I'm working backwards, I'm going to divide the next term by the previous term. So when I do this, and I do 32 fifths divided by 16, and 16 divided by 40, I do get a constant ratio between each one. And that constant ratio is 2 fifths. Again, you guys can use decimals. I'm just going to use a fraction. So if I'm trying to write a sequence, if I now know that this is geometric, there's not much thinking here to do. I just know that my term will be 2 fifths times whatever that term before it was, and that's it. So if it's geometric or arithmetic, it's not bad. So let's look at number 4. Negative 10 to 8 is plus 18. 8 to 18 is plus 10. 18 to 10 is negative 8. So I'm not seeing much of a pattern in there as far as it being arithmetic or geometric. And if I divide negative 18 by negative 8 and then negative 8 by 10, it doesn't give me a common ratio. So what I do next, guys, is I really just think the best way to do this is working backwards. And you guys may find an easier way or a better way that works for you. But I'm going to start with my term of negative 18. And I know that that's my 1, 2, 3, 4, 5. That's my 6th term. So to get from negative 18 to negative 8, if I subtract my terms, so if I did the term right before it, which was negative 8, minus the term right before it, which is 10, I get negative 18. So then let's move down to negative 8. Negative 8 equals the term right before it minus 2 terms before it. So to get to that third term, I'm combining the terms right before it in some way. So in this case, the term I'm trying to find is equal to the term right before it. So that would be just the first one before it, minus the term, 2 terms in front of it, n minus 2, or a sub n minus 2. So again, is there a good way to find these? I don't really have any specific advice or way of doing it, but it really is critical thinking, guessing, and checking. But I do find that the easiest way to do it is to work backwards first and go from there. So let's flip over and I'll try one more with you. Okay, so we're going to do number 5 here. And it gives us a sequence 1, 1/2, 1/6, 1/24, and 1 1/20. So the other thing that's helpful sometimes is putting everything over a fraction if that's what you're operating with or working with. So I see 1/1, 1/2, 1/6, 1/24. So the first thing I'm looking and seeing, okay, well, 1 times 2 gets you 2. 2 times 3 gets you 6. 6 times 4 gets you 24. And 24 times 5 gets you 120. So each time the multiple or the ratio is increasing by 1. But we also have to remember we're not trying to write an explicit rule. So we can't base these off of the term numbers. We have to base it off of the term before it. So if I look at 1/24, 1/24 is going to equal, and we're going to have to somehow use the term before. So how can we get from 1/24, or get to 1/24 using 1/6? Well, 1/6 times 1/4. So this is my fourth term here. 1/24, that's what we're trying to solve for. So there's my n, and here's my term right before it. So 4 is the term number, so 1 over the term number that we're trying to find times whatever that term was right before. And remember, the term is the term value. So 1/6 was the term value right before that. And you guys, if you're not sure, you can always check it. So like, if we're trying to find a sub 3, which is 1/6, does 1/6 equal 1 over the term value, which is 3, times the term right before that, which is a half? Yes. So if you're not sure if you wrote the right rule, check it. You can always check it and make sure. But just remember that explicit is based off the place value, the term number in the sequence, whereas recursive rule has to somehow include that term before. So how can we use the term before it to get to the term we currently have or we're trying to get to? So go ahead and try number 6, and I'm going to go down and do iterations with you guys. So iterations involve the repeated composition of a function. Iterations just means a repetition, essentially. So it's a composition of a function f with itself. And we did do composition of functions in the past. I think it might have been chapter 2 or 3. But the result of one iteration is f of x. So 2 iterations would be f of x. You can use the iteration to generate a sequence recursively, beginning with an initial value, x sub naught or x sub 0. So it says x sub 1 is going to equal the function with x sub 0 plugged in to your function. So x sub 2 would equal your function with x sub 1 in it. The iterate before that, or the term before that, becomes the input for this function. So it says find the first 3 iterates x1, x2, and x3 of the function f of x equals negative 3x plus 1 if the initial value x sub naught equals negative 2. So x sub 1, guys, is just going to be negative 3 times whatever x sub 0 is plus 1. So in this case, x sub 1 is going to equal negative 3 times negative 2 plus 1. Negative 3 times negative 2 is 6, so x sub 1 equals 7. So then I want you to find x sub 2 will equal negative 3 times x sub 1 plus 1, and we just found that. So negative 3 times 7 plus 1 gives us negative 20. And x sub 3, the third iterate, will equal negative 3 times x sub 2 plus 1, and we just found that to be negative 20. So positive 60 plus 1, so x sub 3 equals 61. And that's all there is to it. This would be the first 3 iterates. That would be the first 3 terms of your sequence if you're plugging this value into this particular function. Okay, let me know if you guys have any questions. I know it's hard to sort of switch from doing everything with an explicit equation or rule and then jumping now using this recursive idea, but let me know if you guys need help with anything.